What is the natural logarithm? Well, we saw before that if we have something like 4 to the power of x, and we said maybe we let that equal to a or something like that, we could write log base 4x equals log base 4a, and these two things sort of cancel each other out, or log base 4 multiplied by 4 to the power of x. They're inverse functions, and so we're just going to end up with x is equal to log base 4a. The natural logarithm has a similar relationship to the natural exponent. So if we have e to the x, and I could write, well, how about I write this? We have e to the power of x, and that would be equal to something. If I write log ex, then we know by definition that's just going to be equal to x. And we can think of this parts of the left-hand side as canceling each other out, and the x is all that's left. Similarly, if I wrote e to the log x, that also would be equal to x. We have the e and the log operating on each other, and you can think of them as canceling each other out. And so what is the natural logarithm? Well, it's the inverse of the natural exponent. For example, I might have something like e to the x plus 2 is equal to, let's just say it's some constant a. And maybe I want to solve for x. Well, I can take the natural logarithm, right? And so we never denote the natural exponent as log base e, or at least I never do. It's always denoted as ln. And if I look at my calculator, on my calculator, I've got it in capitals like so, the natural logarithm. So I'll take the natural logarithm, ln, of both sides of the expression. The natural log and the e, base e, are going to cancel each other out, and I'm just going to be left with the exponent, x plus 2, equal to log a, and I end up with x must be equal to the log, or the natural logarithm, of a minus 2. Here's just a very simple graph where we have the natural exponential function, we have the natural logarithm function, and the since one is the inverse of the other, I've also put y is equal to x in the middle. So if we took the log of this thing here, we'd end up with y is equal to x, and if we took the logarithm of y is equal to x, take the natural logarithm on both sides, then we get the natural log function. Rules for the natural logarithm. are just like the rules for any of the logs we saw earlier. So if we have the natural logarithm of a plus the natural logarithm of b, that's like the natural logarithm of a times b. And if we had the natural logarithm of a minus the natural logarithm of b, that would just be like the natural logarithm of a over b. If we wanted to take the natural logarithm of x to the power of a, that would be equal to a log x. And so these are all the same rules that we saw before. Since you've done so much homework, you practiced so much with the regular logs, the natural logarithm will be easy. It's a very simple extension. Same rules apply. Here are a couple examples. Why don't you give them a try? Press pause. When you're ready, press play, and we will solve them together. Looking at the first expression on the left, I can directly take base natural log and put left hand, right hand side as the exponents, like so. Notice that, well, we know that e is the inverse of the natural log, and they're beside each other, so they're going to kind of cancel each other out. So we're going to end up with x cubed is equal to e to the power of 6. E to the power of 6 is a pretty big number. But since we have the x cubed on the left-hand side, I'm going to raise both sides of this expression to the power of 1 over 3, 1/3. And now we're going to have x is equal to e to the power of 2. And of course, e to the power of 2, e is just a number. So if we want to go a little bit further, we could estimate it using decimals and say x is equal to, well, my calculator tells me it's equal to 7.389. Looking at our next problem, we can use the same procedure. Notice that on the right-hand side, this is just a number. E to the power 4 is just a number. And a is a constant number, so it's just a number. So maybe we'll move a over the right-hand side. So let's divide both sides of the expression by 1 over a. 1/2 x plus 2 is equal to e4 divided by a. And now we'll take the natural logarithm of both sides of the expression. So we've got natural log e 1/2 x plus 2 is equal to the log of e4. I could even go minus log of a. So we're doing two steps at once. And we've got a function and its inverse. So the exponent, what's left is just going to come down. So we've got 1/2 x plus 2 is equal to log of e to the 4 minus log a. I want to move the 2 over the right-hand side, multiply both sides of the expression by 2. I'm going to have x is equal to log, well, of course, we've got a log and an exponent right there. So we're going to be left with 4 minus log a minus 2. And this whole thing is going to be multiplied by 2. So we've got x is equal to 2 times 2 minus log a. And I could leave it like that, or I could write it as 4 minus 2 log a, like so. Here's a problem for you to try. Press pause on the video, give it a shot. When you're ready, press play. We'll walk through it together. Now looking here, I see I've got a log here minus a log there. So if I try to take the natural exponent right away, like we did in the previous problems, I get, oh, I've got the sign wrong here. I get something rather ugly and kind of difficult to work with. But we know that the log of A minus the log of B is equal to the log of A over B. And so I can rewrite this as E log x minus 2 over 5. And if I do that, I should have had an E there. Got an E there. And if I do that, these two are going to sort of cancel each other out, so to speak. So we get x minus 2 over 5 is equal to e to the power of 2. Now all I have to do is solve for x, keeping in mind that e to the power of 2, that's just a number. So we're going to get x minus 5 is equal to 5 e to the power of 2. X is equal to 5 e to the power of 2 plus 2. Now if I wanted a numeric answer here, I could say, well, x is equal to e to the power of 2 times 5 plus 2. I put that all into my little financial calculator and I get 38.945. Now here I am on ALEK's, so if I want to put in my answer here, let's see if we've got the right answer. We have 38.9, I'll try 95, and click the check button, and we got the right answer by using the natural exponent to solve for x.